Good morning and thank you for joining our webinar. I reminded you that the webinar is recorded and it will be published on our website under the file service webinars, together with the previous sessions. All attendees are muted. In case of any issue, please raise your hand and I will contact you privately. Please do not hesitate to write any questions regarding today's topic on the Q&A box on the right side of your screen. We will answer the questions and answers on the end of the event. I will now give word to my colleague, Peter Balzer, who will present you today's topic. Again, for people who are just connecting just now, I remind you that the webinar is recorded and it will be published on our website under the file service webinars. All attendees are muted. In case of any issue, please raise your hand and I will contact you privately. For questions regarding today's topic, please not hesitate to write them in the Q&A box on the right side of your screen. We will answer them at the end of the event. I will now introduce you my colleague, Peter Balzer, who will present you today's session. Thank you and enjoy the webinar.
Hello and welcome everyone to the fourth part of the training. My name is Peter Balzer. I'm an application specialist for our joining systems. Today we have three different topics. I'm starting like always with a short presentation to go through the different topics. So first I would like to start to show you the setup of external sensors. So I prepared my demo unit with an external displacement sensor. It's an incremental one, and also with an external strain gauge sensor, and show you how you can set up these sensors in the maXYmos NC. The next topic is data export. I will show you how you can implement or activate our simple data export for the standard protocols, how you can export some CSV files from the maXYmos NC directly to a server or to your laptop, XML file, PDF file, and some universal variable table, some process values. And the third topic, the last one, is I would like to show you our software features. So we are having a maXYmos offline tool for simulation of the maXYmos, and also ECPC software to do some analysis for the recorded curves for the CSV files, for example. Let's start with the external sensors. I show you this picture because that you know how my setup is on a demo unit, because unfortunately I don't have a cam right now available. So here we have mounted an external displacement sensor. It's our type 2122B with the measuring range of 50 millimeters. It's an incremental displacement sensor. The external force sensor I'm using is the type 4577A. It's an external strain gauge sensor with a maximum load, in this case, of 5 kilonewtons. So it's a little bit oversized for the spindle. Okay, so this is the setup I'm using for the external sensors. And I would like to continue with the data export. So we have a lot of different data exports available. We managed it to split it into standard protocols, which contain CSV files, PDF, XML files, and also some single process values in the text data. Then we also support QDAS data export, QDA9, and IPM. IPM stands for Integrated Process Data Management. That's a special database. I just want to let you know that QDA9 and IPM is available. Unfortunately, I cannot simulate it because you need some special software for it. Some of our customers are using it. If you are one of those who are interested in how to set it up, I can of course show it, but I would keep it with standard things like CSV files and QDAS in this case. Okay, so for the standard protocols, here you can choose first of all your export format. Like I already said, CSV, XML, PDF, and also PVT is available. And you can use the USB export. I don't want to show this one today. I would like to show you how you can directly export the files to, in this case, my laptop, or also some network-based storage would also work. For example, some NAT or something. I show you the setup and how you can receive the files on your PC. Here is the screen for QDAS. I also want to explain this. You need to adjust also some parameters, not only in the global setup. here in the data export screen, you also need to set up the parameters in each measuring program. I will show you this also. And the last one, I just want to skip this one. I just want to let you know that these are available. It's QDA9 and of course IPM. As I already said, you need some special software to use it, so I just want to skip this one. Okay, so the third topic is our PC software. In this case, it's the offline tool. We have an offline tool available which simulates more or less the whole maXYmos NC. So you are able to, for example, load and backup from a real maXYmos NC. It did some settings, for example, change the joining profile. You can also implement or import some CSV files that you can offline adjust your evaluation objects. Software is available for the maXYmos NC, which I'm showing today, but it's also available for our second device, the maXYmos TL, which is not used in combination with a joining system. And there are some other new functions with our latest firmware. You can directly make a backup with an maXYmos if you are connected via Ethernet. I want to show you all the possibilities with this software. And the last software I would like to show you is the so-called PC software. It's also used for the maXYmos NC, the maXYmos TL, and in this case also for the maXYmos BL. So I would like to show you this one. You can make a backup, you can make a restore, you can install a new firmware, and also, of course, you can use this software to do some analysis of the curves. And the good thing is you can also create some easy statistics. That's quite useful in some cases. Okay, so let's start with the live session with the external sensors. So now I'm gonna share the VNC. Okay, so like always, I prepared already two different programs. The first one is an external displacement sensor with this incremental sensor. Let's have a look at the setup first. So generally, you have two possibilities. So you can set up your external displacement sensor in the global setup, but this does only make sense if you're using this external displacement sensor for each program. If you use the external displacement sensor only in one or two different programs, it's much better if you use the advanced configuration of each measuring program. In this case, here, advanced channel X, and here I've just set it up, this external displacement sensor. To use this measuring program specific sensor, you need to disable this one. It's do not use global setup. Then you can choose here, for example, the used sensor type. In my case, it's incremental, but you see also plus minus 10 volt sensor is possible, depends on what sensor you're. For this sensor, the type 21B is incremental. In this setup, you can choose your electric interface, differential, push-pull, or open collector, depends on the used type of sensor, and your interpolation factor. That's the setup for incremental TTL. The second page, range and scaling, you can set up your used range. So the sensor has an absolute measuring range of 0 up to 50 millimeter, but I set it up like this because I'm only using a short range, only 8 millimeters in this case, 6 millimeters, sorry. You can choose your decimal places, and the scaling, you can use the teach-in function, which is always often used for example, plus minus 10 volt sensors. But if you have an incremental or an absolute encoder, it makes sense to use scaling by calibration sheet. Then you can have a look at the data sheet of the sensor to see how many pulse count per millimeter this sensor got. In this case, this sensor resulting resolution of 0.005 millimeter. And because of the direction of mounting, I'm using the invert counting direction. Otherwise, if I would not use this one, I would drive from 0 to minus 50 millimeter with my mounting. In the second page, on the fourth page, you can choose the referencing. There are 3 options. This is the standard option, is with measurement start. This means later on, if we have a look at the sequence, the sensor will be automatically zeroed when we are reaching the measurement start tool in our sequence. Another option is, for example, in 0, this is an additional input from the PLC side. So the PLC can freely decide how the sensor should be zeroed. And if you're using a special sensor which has an integrated index mark and hardware index mark to zero it, you can also apply this one. In our case, I'm using the standard function with measurement start. Okay, that's the setup for the external sensor. So I'm using this sensor only in the measuring program number 50 in this case. So now let's have a look at the sequence. So now, because of the mounting, I need to, first of all, go down to a position where the sensor is touched. In this case, it's absolute from the encoder position, 30 millimeters with 100 millimeter per second, and I'm starting the measurement. Then I'm slowly touching the sensor to avoid any damages on it. It's also attached to the reference position of the joystick. It's relative, in this case, 8 millimeter further. And here you see the idle stroke down to 75 millimeter of 100 millimeter per second. This is the position before I'm touching the rubber. It's also referenced to the internal absolute encoder. And now you see in this joining stroke motion, you see now it's referenced to the external sensor. When you set up an external incremental sensor or also an analog sensor, you have possibilities more in this case. These two are referenced to the absolute encoder of the joining system of the motor, and this one is referenced to the external sensor. You can choose external absolute, or you can also choose external relative. If you, for example, want to drive 1 millimeter further, you can also apply external relative and add 1 millimeter here in this case. But I'm in this example working with the this absolute position. So now the spindle will stop when the maXYmos NC received a position signal of 46.5 millimeter from the external sensor. And all the other motions are, like usually, based on the internal absolute encoder. So here you can freely choose which one you want to use. If you set up an external sensor, an external displacement sensor, like in this example here, the evaluation is always based on the external sensor. So it's not possible to switch to the internal one, but we are currently working on a software which this one is also possible. Then you can freely choose, do you want to shut off, for example, of an external sensor, but you want to use also for the evaluation the internal one. So both will be possible, but with this actual firmware, it's only possible to use the external sensor for the evaluation. Okay, so now I'm switching back to my PLC program and starting cycle. You already see the curve, it's nothing special. So here you see now the spindle is moving and now it stops at 46.535 millimeter. So we exceed the target position of about 0.04 millimeter. To avoid any exceeding, you may remember the second part of the training where I showed you how this block motion control works when we have the condition force. More or less the same is also available for condition position. If we have a look here, for example, at this one, you see it's based on the internal absolute encoder. Here you don't have any options to set, but if you set it to the external one, you can set up in so-called offset start break ramp. This means here you get a recommended offset of minus 0.1 millimeter. So now let's try this one. Let's take minus 0.2. And this means minus 0.2 millimeter before we have reached the target position from the external sensor, the spindle will start to decelerate to avoid any exceeding of the target position. Let's see let's have a look at the difference. So same cycle, only with this recommended offset. Now let's start another cycle, 46.535. And now we managed it to get down to 46.505. Please note the resolution of the sensor is 0.005. So we can't get lower than 46.505 in this case. So now we have more or less no exceeding of the target position. And this allows you also to go a little bit faster. So now we are working only with 10 millimeters per second. We can also try 20. Maybe we need to increase the offset a little bit more after because we are quite faster. but this is also possible. So now this function allows you to go quite faster to your target position with an external sensor. So now we exceeded about 0.02 millimeter. And now if we adjust and increasing the offset of the deceleration ramp a little bit, we can decrease the exceeding a little bit. So let's try. Now it's recommended minus 0.23. Let's use 0.4, for example. And this is a way how you can easily save some cycle time because you can go faster with each part. Okay, so now we have the same result like before. As I already said, the resolution of the sensor is 0.005, so we can't get lower than this value. So that's the setup for the external sensor, quite easy. Okay, so the next program I would like to show you is 51. Here I've already implemented this external strain gauge sensor, which you saw on the picture. Let's have a look at the setup. I'm also using the advanced setup for each measuring program. You can also do it globally if you're using this external sensor for all measuring programs. Otherwise, I really would recommend it to apply it only in the measuring programs you are using these external sensors. So in this case, it's a strain gauge sensor. Range and scaling. Here, the maximum load of this external sensor is 5 kilonewton. Decimal place is 2. And here I'm using scaling by calibration sheet. The sensor has exactly 1 millivolt per volt output voltage. Here, with this external strain gauge sensor, it's really necessary to use this 0-point calibration or 0-point adjustment. Otherwise, you will notice an offset when you are cycle. Then you will never start with exactly 0 kilonewton. You will always have an offset. So in this case, I haven't any tool mounted or something. But if you are using the strain gauge sensor inside of the spindle, this is very important because you can imagine if you apply a tool of 50 or 100 kilograms, this will always have an impact on the strain gauge sensor and also leads to an offset for starting the measurement. For an external sensor, it doesn't make sense, but for the internal one, this one is necessary. Okay, it's not too much, only 0.06 millivolt, but it makes a difference because otherwise it will get displayed a few newton. It's not necessary. Okay, so now we have channel Y. It starts with 0, and now I just need to adjust the demo unit. Okay, so I just need to manually place the external sensor directly under the demo unit. So now we can program. So I'm driving quite slowly. Okay, so now you see we have reached 0.83 kilonewton with the external sensor, and the setup of the sequence is more or less the same. It doesn't make a difference if you're using the internal or the external one. If you have a look at the motion, here the condition is force, and there is no option like with the displacement sensor, external force sensor or something, because now this measuring program is referenced only to this external force sensor. There's no option to use the internal or external one. If you set up an external one, it's always used also for the evaluation. So now for the setup of the sequence, it doesn't make a difference if you're using the internal or external sensor. Okay, that's it. That's the external sensors. One program for the external displacement sensor where you can choose in the sequence what is your reference for the motion, the external one or the internal one. The evaluation is always based on the external one. And for the force sensor, there is no difference for the setup of the sequence if you're using the internal or external one. Now I need about 1 minute to adjust the demo unit back to the normal condition, so I give the word back to Valentina for a short break. I'm right back.
Thank you, Peter. In the meanwhile, I remind you, if you have any questions regarding today's topic, please do not hesitate to write them in a Q&A box on the right side of your screen. Thank you.
Okay, so I just unmounted the external force sensor and also the external displacement sensor. So now we can continue with the data export and using the normal internal sensors. Okay, so I've prepared two programs to show you the data export functions. Measuring program number 55 is 54, sorry, is the same I used in the third part on Tuesday to show you the different evaluation objects. So now I've chosen the program with these uniboxes. Okay, to the data export, you can set up the data export in the global setup. You go to global setup, you see here the data export screen. And here you can choose, do you want to use the standard protocols, QDAS, QDA9 or IPM? So we are starting with the standard protocols. So first of all, you can choose which export format you want to export. In our case, I would like to use the CSV file. So I can apply export to server. I can choose a subdirectory. So for example, I can use CSV. And of course, you can also choose a sub automatically graded by the maXYmos NC, for example, for datetime, part ID, or whatever you want to use. In my case, I don't need a subfolder. You can choose if you want to export all parts, only the good parts, or only the bad parts. So these are the possibilities. And you can also choose the CSV format. Do you want to use comma, semicolon, or point comma, or whatever you want to use as Excel. Okay, so I will activate now the export for all different formats. So in this XML, also for PDF. PDF, you have an additional option. You can have in so-called full PDF or only in small brief. I'm working now with the full version. PDF, and the last one is the so-called exported process value table. You can also choose only OK or NOK. And this especially can also be triggered from Fieldbus. There's a special bit available on Fieldbus where you can activate this export format. You can also use the internal file system, but I wouldn't recommend this one. If we are talking about export of some program use, I always would like to directly export it to a safe storage. So in this case, you can, for example, use my laptop or any PC in the machine or whatever you have. Okay, so now I activated all exports. Okay. So now let's switch to server. So now here I just typed in my IP address in the network from my laptop. The user, especially since Windows 10, it's really necessary that you implement a domain. For example, if you have a local user on your laptop, like my setup here, you can only use the star for any domain, / and the Windows user. So I've created with my laptop a special user for all exports from the maXYmos. So this user is called extern. Then then type in the password of this Windows user, and then you need to share a folder. In my case, I also have shared a folder with the name extern. Okay, so apply this one, and then you can directly see if the connection is established or not. If you're going back to the main screen, let's have a look at it. If you press on it, you can see which export is enabled and what is the status. Do you have an active connection or not? So in my case, my free space of my hard disk now is 260 GB, so I can export a few CSV files. If you have a smaller hard drive, for example, for a network drive or something, you will always get a free space displayed. Okay, now I would like to share the folder. So. Okay, so now here is my shared folder. It's called extern. Now I'm just reducing a few parts. Just need to have a look at the program number. It's 54. Okay. Now I'm starting a cycle. automatically see the maXYmos NC now automatically created in CSV folder, in PDF folder, PVT, and XML. Now let's have a look at the CSV file. Open it. So that's our standard CSV file. Contains more or less all measuring values and also some additional information. For example, your setup of the sequence. And at the end of the CSV file, you see the single measuring points. So now, in this case, with this measurement, I've recorded 4,344 measuring points. And here you are also able, for example, to set up a diagram with Excel now to just see the measuring curve. So that's the CSV file. Now let's have a look at the PDF. PDF looks like this. Now you directly see here, there's a short diagram. Okay, something is wrong with the zoom settings. I will, in the next step, show you how you can adjust this one, that you have the same like in the maXYmos. The PDF also contains, of course, all evaluation objects, all measurement values. In this case, I have 6 boxes. They are all displayed here with the according result and measuring values for it. And also, just like in the CSV file, with this full exported PDF, you also have some additional information like channel X, channel Y settings, control settings, evaluation settings, and so on, and also some servo settings for the NC settings in the global setups. And also, your sequence is displayed. Label, idle stroke, joining stroke, and so on. So all information's in this PDF. Okay, the third one is the so-called XML. I'm using always Notepad++ to have a look at it. It's much more comfortable. You can see the XML. It contains also the same information like CSV and also the PDF. You see here the 6 different evaluation objects. First the set points, then the results, and so on. And also additionally all measuring points. So here you see point number 226, 227, and so on. So for each measuring point, you have one displacement and one force value to set up your graph, for example, in any database or something. And the last one is so-called PVT. PVT is quite easy. So here you see, if you're using the text editor, you can't see much, but there is an option in Excel you can use. I just want to show it. So if you open up Excel, you can import this file. Chose the wrong one. So now I need to go to the folder, this one, PVT. Then you can have, for example, an Excel sheet like this. Takes a little bit of time, and then you see it's owned now one measurement, but you can set up, for example, up to 50 cycles or even more for each cycle or for each file in this case. And here you can have a look, an easy look at the process values, which I see also in the table. So here, for example, Unibox 1. And if you have a look at the device, you will see, in this case, I only set it up result, but I can also choose, for example, maximum force of each value of each window and so on. Then you would also see it in this export format. So these are the 4 different export formats. And now I just would like to show you an additional feature, which is quite helpful. So now I have just chosen another program with one difference. It's the same program, but here I'm scanning a barcode first, like I did it in the second part where I've explained all these sequence editor elements. Here I'm scanning a barcode, and now in this data export screen for setup, you can choose, because here this is an automatically created file name from the maXYmos NC. If you don't want to use this one, you can use only the part ID as file name. There's only a single checkbox you need to apply. This one, for example, for CSV, the same for XML, and also for PDF. And then when I'm driving a new cycle with this program, I'm scanning in barcode. It doesn't matter if you are directly scanning in barcode with the barcode element, or if you send the part ID via field bus. Both is possible. So now I'm starting in sequence. Now I'm scanning in barcode here. The sequence starts. And now you directly see the file now is exported with the barcode name. And you directly see it here on the device. So that's the barcode I've scanned, and that's the exported file name. So this makes sense if you are transferring the part ID before you are pressing in the part, then it makes sense. For PVT, this is not available because in PVT you can set up to, I don't know, I think 100 cycles in one file, so it doesn't make sense to use the part ID for one part ID for more than 100 different parts. But for XML, it's available. Use another one. And a third one. That's a good way to separate your parts if you send before you run the cycle and part ID to the maXYmos NC. Available for PDF, XML, and CSV. Okay. So that's more or less the data export for the standard protocols. Now I would like to continue with the export for the QDAS files. So for QDAS, you first need to activate the export in the global setup. So entering the QDAS screen, also enable export to server. The same address like in the standard protocols are used. So even if you do not export some standard protocols, you need to configure the server here, the server IP, username, and so on. It's used for all export formats in this case. So QDAS, enable the export. I have chosen now in a subdirectory with QDAS. Here you can choose your option, which output file you want, DFQ or the view possibilities, depends on what you want to use. You can also use a catalog file if it's available from your company. You can some keys, but first you need to apply. This is typical for QDAS. First of all, you need to activate the usable keys for the user. For example, batch number, event, machine number. You see there are so many different possibilities. So normally this setup is fixed for each measuring program. If you set it up like this, you can go to the measuring program and select your measuring values which you want to have exported in QDAS. So you need to enter the measuring program setup. In our case, yeah, let's use the barcode one. With advanced. And here you see the QDAS screen. Entering the QDAS screen, it's more or less the same like the process value table. So in our case, we have 5 or 6 uniboxes, which I just set up something here. So for example, unibox 5, the maximum force and the maximum displacement depends on which values you want to have. You can also add some special keys for special programs if you're using a key only for one measuring program, for example. Otherwise, the globally set it up keys will be used. We activate this, and I'm running another cycle. Scanning a barcode. Now you see there's an additional folder with the QDAS file, which you can use. That's it. It's pretty easy. You need generally activate the export in the global setup, and then you need to choose which values you want to have in each measuring program. So that was the standard protocols. In QDA9 is a mix of CSV files and QDAS. And IPM is something completely different. You need a database for it. That's the only setup you can do. So I can't show very much here. This is really only important for the ones who are using it. But for the most, I think they're using standard protocols, or QDAS is also quite popular. Okay, so that was the data export. So now I would like to continue with the software. So let's start first. I just need to adjust something here. Just a moment. Okay. So now this is the so-called maXYmos NC offline tool, or it's also available for the maXYmos TL. First of all, if you open up the program, you can choose File New, and then you can choose, do you have in maXYmos TL or NC, and then this screen appears. So before I'm starting with the offline tool, I just want to show you the configuration manager. So with the configuration manager, you have the possibility to directly download and backup from the maXYmos if you have an established Ethernet connection. So if you go to the configuration manager, download backup from maXYmos, and type in your network address. In my case, it's this one. Oh. Then you can check your connect. Device is reachable. That's good. Then you can choose your path. This one, for example. Save and press download, and then a download on backup will be directly created from the maXYmos. It's completed. And in the same way, you can also upload and backup to the maXYmos. So if you have an established connection, Ethernet connection to the maXYmos, you can also upload and backup like this. The same like before, type in the IP address, test the connection, select your path from the existing backup. If you press OK, you can freely choose what you want to restore. So for example, if you have two different systems in one machine, you set it up the one completely. You can also only transmit, for example, the field bus settings. If you have some special field bus configuration, or you can also add the access protection only, or each measuring program if you want to restore in full backup. For example, if you need to, for any reason, replace the device. So everything is possible. I do not want to upload it because it takes too much time, but this is possible if you want to make and restore, not via USB, via Ethernet. Then you can use also the offline tool. Okay. So now, if you want to load any CSV files, or first of all, the backup into the maXYmos offline tool, is just like with a real maXYmos NC. You need to go to Global Setup. You can choose the backup and restore screen, and then you can choose restore and load the file of the backup we just did. For example, backup zip. The same screen. Select all for the full restore, and then the restore is running. And then you have the same setup here in the maXYmos NC, or in the maXYmos NC offline tool, like in the real maXYmos NC. So here you don't see all measuring programs because they are not here. If you enable everything, you see all measuring programs are available. And now these are the measuring programs from part 3, where I've explained all the different evaluation objects. So now a good thing is you can also add some CSV files into the offline tool. So for example, here we are in the history curve. You can press this button. And then you can select single CSV files, or you can also select a zip file with only one CSV file is also possible. So now I need to copy some CSV files, or let's use directly the ones we just created. So I need to search for my folder. This one, CSV, and let's use these 3 files, for example. You can load this one into the device. Successfully imported. And now it's important. You need to refresh. Select the measuring program. And then you have these 3 curves, which we are just created also in the offline tool. And now, if you go to the measuring program, in this case, it's 54. Evaluation. You can also just the real maXYmos NC. Now you can choose if you want to implement some reference curve. You can now choose your history, go into the history buffer with these 3 curves, measuring program 55, and insert. And then you see the reference curves here, which we just imported. So that's quite useful if you just have a backup, the machine is running, and you want to offline edit some settings, for example, evaluation objects or something. You can use the offline tool. You can do your changes now. For example, I don't know, for example, shift some evaluation objects, doesn't matter. Then you can accept it and create a backup and restore it on your real maXYmos NC. You can do it with the pen drive, or you can use this function when you have stopped your machine in the production. So that's quite useful. You can do everything in the office. That's a good thing. Create a backup. File name. Let's name it, for example, training. Choose your path. Okay. Now the backup is created. It's called training. And you can restore it on a real maXYmos NC. So that's the function of the offline tool. Additionally, there's a so-called print setup page. So if you want to print, you can really print it on a piece of paper, but you can also print it as a PDF, for example, the settings of the maXYmos NC. If you want to have a list, a piece of paper or something, not only an XML where all the settings are stored, you can also directly print it. We can have a try, for example, let's print measuring program 54. And also I would like to have the global settings. Save as. Let's save it on the desktop. Print. And then it's sent to my printer, and now I can use PDF. And now you see, I need to, there are a few pages. I need to save it first, and I can show it. Okay. Just a moment. I need to search for it. So now I share my screen again, otherwise it will be too difficult. Okay, so now you should see the PDF file. That's the setup file which is created with the offline tool. There are 2 different setup files, one for the measuring program, and I also selected the option choose also the global ones. So here you see it on the file name. One is for global and one is only for the measuring program 54. So this is only the setup from the measuring program. So some people like it to have a piece of paper with the information instead of a file. So if you want it, have it in this way. You see it reminds a little bit on the PDF export. It's more or less the same information. Okay, so this is also possible with the offline tool. And one additional information regarding the offline tool. Let's go back to it. When it was successful. Okay. So there's another option. It's called convert backup. If you go into this function of the offline tool, you see you can select a file. Let's select an offline backup, for example, this one. And you can convert it to a version between version 1.3 and version 1.5. This has a reason. So here I'm working with our latest firmware version. It's called version 1.66. in version 1.6, we have implemented so many new parameters that we need to adjust the setup configuration. So this is not possible to load a backup which was created with version 1.6 in a device which has, for example, the software version 1.3, 1.4, or 1.5 running. So you need this function if you want to make a backup of a device which is actually running with version 1.6, and you want to install this backup into a device which is running with an older firmware version. This is necessary since version 1.6, and this is why we've implemented this small tool into the offline tool. So now you can say save file, you can choose your path, and then it's called backup converted. And then you can load this backup file into a, like I already said, in a maXYmos NC with the firmware running version 1.3 between 1.3 between 1. If you are using a 1.6 version, you don't need to convert anything. It's only necessary if you are making a backup with your firmware version and want to install it in the lower one, then it's needed. Okay, so that's the offline tool. Now I would like to go to the last part. That's the so-called maXYmos PC Plus version. There are two versions available for this PC software. The so-called basic version. Basic version contains only this function which you are seeing here in this page. First of all, you can add a new device. Sorry, this was a new group. Yeah, you can split your devices if you are connected more than one device in different groups. But yeah, okay, if you need it. I never needed it. So here you can choose your device. In my case, it's already activated. So you can search for it, and then you see directly the serial number of the device. And you can also do some diagnostics to get the firmware version and so on. But you can implement this one. In my case, it's already, so I just need to press connect, and then the device is connected. Here you see the actual displacement value, actual force. You see the installed firmware version. With this function, you could install a newer or a lower firmware version. You can create a backup and a restore, just like with the maXYmos NC offline tool. We just implemented this and a backup function also in the offline tool because a lot of customers are only working with the offline tool and they do not want to switch between two different software versions. This is why we also implemented it in the offline tool. With older versions of the offline tool, backup and restore is not possible. So now these are the basic files. Create a backup, do a restore of your parameters, install a new firmware, that's it. If you have the Plus version, there are a few more possibilities. You can, for example, add a few screens here. One is, for example, displaying the current curve. One is displaying some statistics. The other one is displaying, for example, the process values. And another one can displaying some errors or something. Or simply in smiley. Both is possible. And I know a few customers which are displaying this screen here on a big monitor up their production hall. So you can also add, for example, all devices from your machine. For example, if you have a machine with 6 different maXYmos NCs, you can create a window for each maXYmos NC, and then you can directly see if something is going wrong with one maXYmos NC. You have any fault or any station or something, then you can directly notice it on a big monitor production hall. I saw this a few times, so this page is used quite often. The next thing which you can directly do on your laptop is you can use this Explorer function. Explorer function means I just prepared a few CSV files. So here on the left side, you can select a folder which contains some CSV files, and then you can have a look at the graph. So let's start with the general setup. So first of all, if you select a CSV file here, you see the part name, part ident. If you would transfer a part ID from the PLC or just scan it with the barcode scan, in this case I haven't used it. I done this yesterday. So here you see the type number of the device, firmware version, serial number, that's the general information. You see some curve values. Curve values are independent of each evaluation object. So this you will see every time. For example, maximum displacement value and also maximum force and the peak force. So these are the general curve values you can directly see for each CSV. So here it's always the same cycle. You see the curves are more or less the same, but here you see the values are a little bit changing. Next is evaluation. Here you can see all the evaluation objects. In this case, I only have this no pass threshold available. If I would choose a CSV, or I can also choose, let's try just the ones we exported so we can see a little bit more evaluation objects. Here, CSV file. Okay, so now you can see how it looks with more than only one evaluation object. And here you can jump through different evaluation objects and directly have a look at the results. That's pretty useful. And also, if you continue with the details, here you see all the single measuring points. And the good thing is now we have 4 measuring points, so I need to jump a little bit further down. But if I select something like this and you activate the crosshair, you can directly go through the graph with your keyboard. So that's quite useful. Yeah, here we have so many measuring points, but in normal cases you only have 500 or 1000 maybe, then it's a little bit easier. But it also works like this. You can also zoom in a little bit, for example, like this. If you're holding the left mouse button, zoom out, zoom in this area, jump to it, like this, and have a look at each value. The good thing is here you have on the left side the displacement value, the force value, and in the same view also the time value. For some applications this is quite useful. You can choose your zoom settings from the maXYmos, like it's set up in the maXYmos, or you can display the whole curve before measurement starts. You can also have a look only on sensor Y, so only on the force values depending on time. You can also have a look only on the display values depending on time, so both is possible. And also you can use, now I don't know if it's working, now marks means now you see graphically each single measuring point. So now if we zoom in a little bit, you see there's a mark, there's a mark, there's a mark. So here you see all the single measuring points. You can also use the so-called bundle function. Bundle function means now you can overlay, so in this case we only have 4 curves, but you can overlay 4 curves, and now if they would be different, you see how stable your process is. And especially this is a big help if you do not have any set points for your evaluation objects. You can do it during the production, that you see, okay, how stable is my process, what are good parts, what are NOK parts, and choose here your limits for your evaluation objects. If you don't have any hard limits from the development or something. And also an additional thing I would like to show you, I'm using this quite often. For example, if you have a cycle like this, you can create a so-called statistic Excel sheet. Example, let's name it test. Simply press on this button. And then an Excel file will be created. And then you have more or less the same view like we had it before with this PVT export. Now you see, here is one side. Now I forgot to bundle it. Now you see only one curve, but you see the file name, date, time, status, and all the values for each evaluation object. And now I'm doing the same only with the bundle function, because only one is a little bit less. So now bundle, create statistics, test, and now hopefully exported everything. No, it's still only one curve. I'm not sure if something is missing. Maybe it's because of the different part IDs. I'm not sure. Okay, anyway. I'm not sure. Normally this is working quite good, but here I just want to show you the files. So here we have all information about each single measurement value from each evaluation. 1, 2, 3, and so on. And now if you imagine if you have 100 cycles or something, for each cycle you got here a row, and then it's quite easy to, for example, ask for the average peak value for the force and so on. So that's quite useful. Okay, so now I'm finished with all the topics for today. If you have any questions, please put it in the Q&A box.
So we have some questions. First one, could you please explain convert backup in offline tool?
Just a moment.
And how can we download the maXYmos offline tool?
So just a moment, I had a problem with the visualization of the okay, so the first one is convert backup in offline tool. Okay, so well, I explained it. So if you go to convert backup, so this is really needed if you want to make a backup with version 1.6 and you want to install or load this backup into a device which is lower than version 1.6, like it's written here between version 1.3 and version 1.5. Then you can choose a backup file which was created with version 1.6, for example, this one. Okay, you can go to save file, select, so I can overwrite this one, you can press convert, and now you can load this file which was created, this backup underline convert zip, into a maXYmos which is running with version 1.3 or version 1.5. As I already said a few times, it's only needed if you're running a maXYmos NC with version 1.6 and you want to load this file or this backup into a maXYmos NC which is running with a version lower than version 1.6. Okay, so the next questions I see are 4 questions in a row. How we can choose different range in force sensors? That's quite easy. So I'm going back to the real maXYmos NC. So now if I'm selecting a program, so now in this case it's measuring program number 55. I'm just displaying everything. I just hiding everything else for a better overview. Just a moment. So okay, so now only the VNC is visible. Okay, so there's the Q&A box again. So okay, so if you have a spindle with a piezoelectric sensor, this means your channel Y setup looks like this, plus minus 10 volt, 2 ranges. Then you can choose in the measuring program 55, for example, in the advanced settings, you can go to channel Y, and here you can choose, do you want to use the big measuring range, or the lower one with 500 Newton? Okay, the next question is, can you show again the backup settings in global setup? Of course, I can do it. You go to global setup, backup and restore. So now we are connected with the real maXYmos NC. So now just can put in my pen drive just to explain how you can do backup. If you connect in backup, it takes a few seconds till it recognizes the pen drive. Then you can press on backup, choose a file name, backup, I don't know, training or something. Okay, apply. And now this backup will be stored on the pen drive. This is the way how you can make a backup on the pen drive, and you can also restore it here via pen drive. Restore, backup, and here you can choose your backup files. So this is my pen drive with a lot of different backups, but here you could choose your backup file. Or you can do it like I explained it previously with the offline tool via Ethernet. That's also possible. It's not the next question is it possible to connect laptop later and export the data? Generally, this is not possible. What you can do is you can export your history buffer pen drive. So now I've connected an pen drive, and if you go to the history buffer, you can export this one. So now the storage of the history buffer is 500 cycles, but we extended it in version 1.4. But you need to activate it. I forgot it in this case. If you go to global setup, you can go to extras, and here you have a button extended curve history. It's only one click with the checkbox, and then you can have up to 5,000 measurings or CSV files in this case inside of the device. And now you can export this one. So you can choose your filters. For example, if you want only the files from, let's say, measuring program 54, the result should be only good, or you can also do not use any filter, then you will get the latest 5,000 curves in this case. But I will use a filter, otherwise it will take too long. It's only 134 curves, but anyway, I will use only measuring program 54, so there are 3 curves. You can use this camera icon here. Press on it, you can choose between screenshot or data, and here you can choose which format, CSV, XML, or PDF. For example, CSV. You can choose your file name. Let's name it history buffer train. And then in this backup folder of the pen drive, now you will find these, in this case, 3 CSV files. But it's not possible to connect a laptop later and directly get the data. That's not possible. You need to export it from the history buffer. And the next thing the next question is how we can export the data to USB. I connected my USB. You go to setup, global setup, data export, standard protocols. Now it's the same for each format, but now I would like to show it only with CSV. It's also working with XML or anything else. You need to apply, export the USB. There's an information window coming. The USB data export has to be started separately from USB dialog in process view. That's important. So you can choose directory on your pen drive, for example, also CSV. You activate this one, and now process is still not activated. To activate the process, you need to press onto that icon and sorry, wrong one, pen drive icon. Then you need to say start. Then you see the icon is changing. So that's the icon if the data export is active, and this one is if it's stopped. So you can, for example, if you just want to go through the production and simply, I don't know, sporadically grab some curves from the devices, you can use the export from the history buffer, or you set up the USB export on the pen drive. And if you want to export or grab some values from this machine, you simply press on the you first of all, of course, plug in your pen drive, say start, and now if the production, as long as the production runs, you will receive files exported to your pen drive. And before you unplug it, it's important, press stop and press remove USB stick, and then you will have the curves safely stored on your pen drive. The next question is where we can download maXYmos offline tool. Maybe Pino, maybe you can copy the link from the service download into Q&A box so everyone can.
Yes, absolutely.
Okay, that would be great. Thanks.
There's another question regarding the load backup from 1.0, 1.4 to 1.6. Did you answer already to this?
No, that is the next one on the list. Yes, you can. Yes, you can directly load and backup from 1.4 to 1.6. That's not a problem. The only problem is from a lower to a higher version. It's not a problem. Only the different way is the opposite way is difficult, because you need to imagine if a device is running with version 1.4 and you're loading it with version 1.6. The backup of version 1.6 maybe contains a lot of more parameters which are not clearly visible for the version 1.4, and that's the issue. But if you are working with 1.6 version and you load and backup from 1.4, it's not a problem. Okay, that was the last question what I'm seeing. Any more questions?
No, it doesn't seem there are more questions at the moment.
Okay, anyway, if you have some additional questions after the training, do not hesitate to contact us. Okay.
All right. All right. We wait another couple of minutes and then we close the session, okay?
Okay.
Okay, Peter, I think there's no more additional questions. So thank you, everybody, for your attention. And just as a reminder, you will find in the next days all the backups and store sessions on the website. We will send you the link to download the different sessions from 1 to 5. Okay, and I take a chance also to invite you to the next and last section, which will be next Tuesday, and we will talk about the safety performance of our joining systems. So thanks again for the attention, and we meet next week. Bye bye.
Also, thanks from my side and goodbye. Hopefully, see you next week.